Hello and welcome. In my last video I demonstrated how to sketch or roughly graph a quadratic function, and we went through a step-by-step process that was quite long. So in this video I want to show you where the shortcut formulas that are often used to do the same thing come from. So let's start with a general quadratic equation. Y is equal to ax squared plus bx plus c, and we'll go through the steps on how to graph such an equation. The first thing to do is to determine whether we have a happy looking function or a sad looking function, and that's going to be dependent on the coefficient a in front of the x squared. So if a is less than 0, we're going to get a sad looking function. If a is greater than 0, we're going to get a happy looking function. And if a is equal to 0, well, we're not going to get a quadratic function, we're just going to get a straight line, so we won't consider that case. The second step is to find the y-intercept, and that's quite easy as well. That's done by just looking at the plus c term, or more formally, find what y is when x is equal to 0, and that of course equals c. And the third step is to find the vertex of the function, and I'm going to do that by converting this equation from standard form into vertex form. First let me get rid of these borders around the coefficients. Alright, so we're going to take the function from this standard form into vertex form. And the first step of that process is to factorize out the a. So if I factorize out the a, I'm going to get in brackets x squared plus b divided by a x plus c divided by a. Next I'm going to add another term to this group. I'm going to add b squared divided by 4a squared, and if I add b squared divided by 4a squared, I have to take it away as well in order to make this second line equal the first. Sorry, c divided by a, not 2. So see that this line is equal to that line, because the b squared on 4a squared terms will cancel each other out. But now that I have that term in there, I can group the first three terms together and rewrite that as a squared term. So that's also known as completing the square. So if I complete the square on the first three terms, I will get x plus b divided by 2a all squared. And again, if you're not sure how I got from here to here, please review my video on completing the square, which I'll include a link in the description below. And I'll still have a outside of that. And these final two terms I'm going to group together and form a common denominator between them. If I take out a negative, I'm going to be left with b squared, and I want a common denominator between them of 4a squared. So c does not have a 4 and an a, so I'm going to have to multiply it by 4 and an a to get it to work out with a common denominator that we've chosen. Alright, so if I put a back into the expression, I will get ax plus b divided by 2a squared minus b squared minus 4ac divided by 4a. So this is the equation now in vertex form. So as we've seen from my previous video, the y-coordinate of the vertex will simply be the trailing term, and the x-coordinate, well, that happens when this squared term is equal to 0. So for the squared term to equal 0, x has to equal negative of b divided by 2a. So it's related to that, except for it is opposite of the sign. So this is the formula for the turning point. The final step of the process is to find the x-intercepts, and that occurs when y is equal to 0. So effectively, a multiplied by x plus b on 2a all squared minus b squared minus 4ac divided by 4a is equal to 0, and we solve for x to find the x-intercepts. And I should note here we may get three possibilities. We may get 2 x-intercepts, we may get 1 x-intercept, and we may get 0 x-intercept. And I'll show you how this comes about. Well, first of all, rearranging this equation to get x by itself will simply result in the quadratic formula. And what will determine the number of x-intercepts we have is what is inside of this square root. I'm going to call this b squared minus 4ac. I'm going to call that delta. Okay, let me explain further. So when delta is greater than 0, so if b squared minus 4ac turns out to be a positive number, we will have 2 x-intercepts. And I will show you how that works on a sketch. When delta is equal to 0, we're going to have a function that looks kind of like this. So we have 2 x-intercepts. When delta equals 0, we will get 1 x-intercept. And our graph will look something like this. So the x-intercept in this case is equivalent to the x-coordinate of the vertex of the function. Alright, when we get delta is less than 0, so that means b squared minus 4ac is a negative number. Well, we can't get a real solution when we get a square root of a negative number. So in the case when delta is less than 0, we'll get no x-intercepts. And our function would look a little bit like this. So the function can still be plotted on the real plane, and it will still have a turning point and a y-intercept, but it won't cross the x-axis. and that is where the shortcut formulas for sketching a parabola come from. Please give me a thumbs up if you have found this video useful. If you are a math student, please feel free to subscribe for future videos that may help you on assignments or exams. If you have any question that you would like me to do a video on, please feel free to comment on any of the videos that you've seen. Thanks for watching, and I hope you learned something.